Hello my dear students, in the last class I explained the theory about thick cylinders. Today's class I will solve one or two problems on thick cylinders. Let us take this example. A cast iron pipe of 400 mm internal diameter and 100 mm thickness carries water under the pressure of 8 Newton per millimeter square. Determine the maximum and minimum intensities of hoop stress across the section. Also sketch the radial pressure distribution and hoop stress distribution across the section. Okay, this is the problem given. We have to calculate maximum and minimum intensities of hoop stress. Hoop stress is sigma x, so maximum and minimum intensities have to be calculated, and also have to sketch the radial pressure distribution and hoop stress distribution across the section. What is given here? Internal diameter is given, that is 400 mm, that is D2. Okay, here internal diameter is taken as D2, 400, and so what happens? The radius is divided by 2, diameter divided by 2, so internal radius is R2, that is equal to 200 mm. Then thickness is given, that is 100 mm thickness, and internal pressure of 8 Newton per millimeter square. Internal pressure, that is nothing but Px. Okay, it is given 8 Newton per millimeter square. Now what you have to calculate? External diameter or external radius is not given, so you can calculate that because you have internal diameter and also thickness, right? So how you can calculate? So external radius is it is R1 now, that is 200 plus thickness, that is 100, right? So that means external radius is 300 mm. Then now let us take this sigma x hoop stress or circumferential stress that we have to calculate. Okay, and now let us assume, okay, when the inner radius, that means x, okay, is equal to 200 mm, you can consider R2 also, no problem. When internal radius is R2, that is equal to 200 mm, then pressure is 8 Newton per millimeter square. That is given here. Okay, internal radius and pressure is 8 Newton per millimeter square. So what about the outer pressure? So outer pressure I have given in the note, that is always equal to 0, right? Outer pressure is equal to 0. So when outer radius, what is outer radius? Here inner radius is given 400, so external radius you have calculated already here, 300 meter, so that is R. Okay, R means R1 external radius is 300, so pressure is equal to 0. Okay, when the inner radius is 200, pressure is 8. When the outer, external radius is 300, pressure is 0. Okay, by using this condition, we can solve the problem. Why this is? See, we know these two formulas, right? Radial stress is equal to Px, that is given by B divided by R square minus A, and circumferential stress is given by B divided by R square plus A. Use this formula and find what is circumferential stress or hoop stress. Okay, now first I will apply this Lamé's equation for the inner surface. Okay, now Lamé's equation, that pressure at the inner surface. So inner surface, the pressure is 8 Newton per millimeter square, right? Here this is given when x is 200, means inner radius is 200, the pressure is 8 Newton per mm square. So now pressure is 800, so formula all of you know, right? Px is equal to B divided by x square minus A. Right, this one B divided by R square minus A, that is radial stress. Okay, now instead of this x you can consider it as R also, not a problem. Okay, this is the formula means Px is equal to B divided by x square or r square minus a. Now we have to apply it for the inner surface. Okay, inner surface is r2. Okay, so Px is equal to B divided by, you can write r2 square also, no problem, minus a. Okay, now we know this is B, we don't know, right, like that only, and R2, that is this external radius, that is equal to 300. Okay, so that is equal to, sorry, not external radius, R2 is internal radius, is equal to 200 square. Now R2 square minus a. Okay, so simplify this. B divided by 200 square, that is equal to 40,000 minus a. Now you write in terms of a. How you can write? A is equal to B divided by this 4 into 10 raised to 4 minus 8. This 8 comes that side. Okay, this is the equation 1. Now I apply the same theory at the outer surface. So what is the formula? Now, for the outer surface, the formula is same, only this R2 becomes R1 now. So, at the outer surface, that formula is what? Px is equal to B divided by R1 square minus A. What is Px? At the outer surface, the pressure is equal to 0. So, I have given that in the note. So, when the pressure at the outer surface is 0, write 0 divided by B, and this is R1 square, that is outer radius. Outer radius is what? That is 300. So substitute that 300 square minus A. Okay, so equal to, simplify this, B divided by 9 into 10 raised to 4 minus A. Okay, write in terms of A. How you can write? A is equal to, this is 0 only, so A comes this side, so A is equal to B divided by 90,000. So this is equation 2. Now we will solve equation 1 and 2 by equating 1 and 2. So we will get the constant A and B. So I will equate equation 1 and 2. So what is that? Both are A only. So A is equal to B divided by this 40,000 minus 8 is equal to B divided by 90,000. Because both the equations, we are equating this, both are A only. So I am writing the values of A. Simplify this, you get B is equal to 5,76,000. This is the value of B. Now, once if you get B, you can substitute in any one of these equation, either equation 1 or 2. It is simple. If you, calculation becomes simple if you substitute in the equation 2. So, we have B value. So, write that and divided by 90,000, that gives K. So, A is equal to 6.4. So, now we know what is B and what is A. So, we can calculate what is the circumferential stress. What is circumferential stress? We have to calculate both maximum and minimum. So, how we can write? Maximum and minimum means at the outer surface and as well as the inner surface. Now, hoop stress or circumferential stress, that is equal to, formula is sigma x is equal to B divided by x square plus A, or B divided by R square plus A. Okay, now this is for the inner surface. Inner surface radius is 200. So B divided by that is inner surface radius, that is 200 square plus A. A is 6.4. B also you know, you will get circumferential stress or hoop stress at the inner surface is 20.8 Newton per millimeter square. Similarly, calculate at the outer surface, that is for the radius 300. So B divided by stress, circumferential stress or hoop stress at the outer surface. So substitute again, x or r is now equal to 300. So 300 square here. Now simplify, you get hoop stress at the outer surface is 12.8 Newton per millimeter square. Now you got what is maximum pressure and also minimum hoop stress or circumferential pressure. Now you can draw the sketch. How you can draw the sketch? See, radial pressure is Px and hoop stress is sigma x. Okay, so first let us draw this straight line. Okay, this is the original line. Now I will mark this, I will draw this arc for 200 mm radius, and this is outer radius, that is outer radius is 300, so again 100 more, so this is for 300. Okay, now we have the pressure at the inner surface. For the radius, what is the inner pressure is 8 Newton per millimeter square, that is for the radius 200 mm square. Inner radius, that is for 200, pressure at is 800, and for outer this pressure is 0, right? So for the it is given in the problem, inner radius pressure is 8 Newton per millimeter square, outer radius it is always equal to 0. So join this is 0, 0 to 8. Okay, next you have to draw, this is hoop stress, radial stress. Next you will draw for hoop stress. How it is? At the inner surface for 200, that is 20.8. Okay, so draw this is 20.8 below the line. Okay, and then for 300, that is 12.8. So it is 12.8. Draw this line. Okay, so like this you can draw a radial pressure and hoop stress distribution for a thick cylinder. Okay, now here this is 12.8 at the outer surface, and the circumferential stress at the inner surface is 20.8. Similarly, for the radial stress distribution at the outer surface 0, and at the inner surface it is 8 Newton per millimeter square. So this is same thing, it is shown in terms of radius and hoop stress. Okay, for the outer radius 300, that pressure is 0, and for the inner surface it is 8. Okay, similarly for this is the circumferential stress at the outer surface it is 12.8, and for the inner surface it is 20.8. Like this you can draw, you can calculate first hoop stress or circumferential stress by calculating A and B, then you can draw. Okay, first what you have to apply only those two conditions. What is you have to use only those two formulas. Px is equal to B divided by R square minus A. So by using that equation and applying for both inner and outer surface, you can calculate A and B. Once if you get A and B, you can apply that other formula, that is for circumferential stress, sigma is equal to P divided by x square plus A for both inner surface and outer surface. You will get these circumferential stresses. Once if you get, you can draw the diagram. I hope all of you understood. We'll solve one more example in the next class. Thank you.